Good morning, everyone. I welcome you all to this 13th day of CSIR NET exam training. Past 12 days, we discussed about the main part of CSIR examination. We discussed about some important topics. That is the session 1. In that session 1, we discussed lots about the unit 4 developmental biology, methods in biology, and the unit 4, like these topics are covered in previous day. Now this from this 13th day we are going to discuss about the session 2. Before entering into the session, please confirm, am I audible? Can you see my slides? Is it visible? Please let me know, am I audible? Yeah, okay. Thank you, everyone. Now we are going to start this session. Okay, this is the unit 1, because in this the session 2 we are going to cover the 6 topics. In that 6 topics we are going to study about the unit 1, 2, 4, 1, 2, 3, 7, 8 and 11. These are the important topics. Next, little bit important in the CSIR examination, that we want to give some important to that topics. So today's section is fully going about the unit 1. In this unit 1 we have wide topic, because this unit 1 fully covered the biochemistry Leninger book. Biotechnology peoples, everyone, all biology peoples are know about this this biomolecules related structures and biochemistry related concepts. This unit 1 fully covers the unit biochemistry related topics. In this topic, first is everything. First, every step we want to start up with the atoms. These atoms are made up of the protons, electrons, neutrons. This neutrons is forming the nucleus. Okay, external surface of the atom having the electron, the inner more space having the nucleus. This nucleus having the neutrons and protons. Protons are positively charged, electrons are negatively charged. This is well known one. So just this is refreshment for your brain, because all of them know about this atom related concept, atom chemistry, all about the things. Here in this molecule atom structure, what kind of questions are there means, they are providing the one story about the nucleus. That in that story itself they mention this much amount of protons are there, this much amount of neutrons are there. If there is a loss of neutron, what happen in the nucleus? That kind of questions are there in CSIR questionnaires. Here I mentioned, this is very important thing in understanding of atoms. In this table I mentioned relative mass of protons. This is 2 marks, because as earlier said, in the first day itself I mentioned this unit 1 having the more weightage for the 2 mark question. Part B question. Part B question is small one word questions, one line questions. That is the 2 mark one simple question, simple form of direct questions. This is the part B. This unit 1 carries more weightage for the part B. So in this table is very important. Proton having mass is a 1, neutron having the 1, and electron having 0.0005. They confuse with these zeros. In the option they mention the different number of zeros in different order, so we may get confused. Then relative charge. What is relative charge? First one is relative mass. That next one is the relative charge. In this relative charge part, we know protons having the positive charge, positive 1, plus 1, electron having the minus 1. Then charges, that is relative charge. Now we are going to discuss about the actual charge of the particular electron and protons, electron, neutron, protons. They having the charge 1.6 into 10 power minus 19. The mass is mentioned as the mass of the proton is 1.67 into 10 power minus 21. They confuse the mass and charge. Please remember that charge is 1.6 into 10 power minus 19. The mass is 1.67 into 10 power minus 27. That is for proton. Then electron, minus 1.6 into 10 power minus 9 is charge for electron, and 9.1 into 10 power minus 3 is charge for a mass of the electron, mass 9.11 into 10 power minus 3. So now you understand the difference. Please remember it. This is very important denotions, because in that part B, this unit carries more weightage for part B. In that part B, we having the direct question. That direct questions includes the this values. It may carries the direct values of the minus 1.6, 9.11. They providing it in the option. They confuse the number. Confuses the number. So please memorize this table. Okay, next tentative. Atoms are form the molecules. This formed molecules are based on the arrangement of atom. It varies. We all know about some atoms. We all know some know about the water molecule, right? Water molecule is the basic example for all kind of the chemical reaction, chemical experiment, chemical molecule, chemical structure. Okay, this is the glucose structure. It's having the glucose structure. Then vitamin structure, vitamin A structure, then benzene structure, methane structure. These are all the basic structure molecule. Why I have mentioned this means structure of the molecules is depends on most of the structures. In the worldwide, 82% of structures are made up of the carbon, hydrogen, oxygen. All small molecules, building molecules, are made up of the carbon, hydrogen, nitrogen, oxygen. In that, carbon is most widely playing the role in the structure backbone. That structure backbone of all molecule, the backbone of all molecules are made up of the carbon molecule. Okay, this is the one key question. The backbone of the structure is the carbon molecule. The highly present atom is hydrogen molecule. Please remember, important most backbone is carbon, highly present molecule is hydrogen, and interaction molecule is oxygen. Okay, that interactive in each and every interaction, oxygen plays the vital role, because it makes the bond with the other hydrogens. It makes the hydrogen, it make a bond with C. In that, the center point is oxygen for the interaction. three molecules are widely involved in the structure construction: oxygen, hydrogen, and carbon. In that, carbon having the vital role. The carbon is a backbone, hydrogen is the highly present molecule, oxygen is the interaction molecule. Here the next is here you can see the each and every molecules are having the interaction. In this image itself, you can understand H is most widely present, and the O is for the interaction sites, and in the center part on the backbone having the carbon. These are all the structures of some this is well known to you, but I wish to tell some important thing. Hydrogen having the one valency, so that having one black dot. Carbon having 4, so it's interact look like the 4. Water molecule, in that water molecule we have the 2H and 1O. The interaction happens between the H, so there is 2 valencies are went to the H molecules, so there is only the 2 and 2, the 4 alone is there. So water molecule valency is 8. The ethylene, then ethylene it's also having the interaction, sorry. Then acetylene, this acetylene having the small structure. Okay, next one is this is the one arrangement of structure. If there is a linear structure, means it's in this linear form. Why this atom, the angle between the two atoms, the angle between the atoms are 180 degrees Celsius. A very important thing, this angles and the structure of molecule. This related questions are asked in the CSIR examination. I am experienced with that, so only I am mentioned include this table. If there is a 2 bond, if the molecule having linear structure, the angle between the 2 atoms is the 180 degrees Celsius. It's first thing. Next one, if there is a triple, it's an 3 molecular, 3 bonded but 4 molecule. Here first one is 2 bond 3 molecule, A, B, A. This count is the 3, but there is a bond is 2. Here the bond is 3. The 3 bonds are angled between 120 degrees Celsius. The angle between the atoms is 120 degrees Celsius, means that is the trigonal planar. Then if there is angle between the 4 atoms is 109.5, that is the tetrahedral. Then it may be the pyramid shape. That pyramid shape is also having the angle 109.9. This is the, here one is the bend. Here the hydrogen bonding having the bend, but the angle between the 2 molecule, the interaction site is 109.9. They mentioned it's a bend, or it's straight, or it's in pyramid shape. They mention all the things. We want to understand the concept and mention the degree. They provided if the molecule having the V-shaped interaction, that bonding what is the bonding type, that is the dihedral, the interaction, the electron pair arrangement is the dihedral interaction. What is the angle between the atoms, means that is the 109. All the they provide all the information. Just ask the degree of the angle between the atoms, or they provide the angle and ask the molecular structure. Okay, first atom, then chemicals, then how it interact. That interacted by the chemical bonding. This chemical bonding is having the different types. In this slide, I am included some important concepts alone. In the chemical bonding, we having the ionic bond, covalent bond. In that covalent bond itself, we having two types. That is electronegativity types, polar covalent interaction. Okay, then here we having the types of band with a single type, double bond, and triple bond. There are some other variety classifications. First, in this image itself, I am going to explain the metallic bonding interaction. That is the electron based interaction. Metals and alloys are interacted each other by the electrons, interacted by the this chemical bond, metallic bond. Then what is ionic bond? That salts making the interaction. So metals and non-metal compound interaction. The metallic bond only made between the two metals. Ionic bond made between the metal and non-metal molecule. That non-metal molecule may be the salt, or that salt is NaCl, MgSO4. There is the electron exchange between the atoms. In this case, ionic bond caused because of electron exchange. Ionic bonding made because of the electron exchange. Okay, next covalent bond. In this covalent bond, molecules are formed the network. Full of in this concept we can't. Then this is only applicable for non-metal molecule. The covalent bonding is only applicable for non-metal molecules. This non-metal molecule means that may be water, that may be the methane, hydrogen, oxygen, glucose. So this kind of. In this covalent bond, we are sharing the electron. We are shared the electron molecule. In this previous case, we mentioned ionic bond, that is the exchange. We give one thing, that acceptor, donor, or one ionic metal gives one electron, so non-metal gives one electron. This is the exchange of electron. But here in this covalent bond, two non-metals, the two non-metals, one will be the acceptor, another one is the donor. Okay, glucose and water reaction means glucose provides the interaction, hydrogen electron, water accept the electron. That is one example, not take it, it's just example I am mentioning. One molecule providing the electron, that is the donor. Another non-metal molecule absorbing, that is taken the electron, that is the acceptor. Here the covalent bond interaction is electron sharing among the atoms. Next, using this electron interaction, using this kind of interactions, atoms made up of the atoms helps to build the molecules, that molecules helps to build the bonding. Now with this bonding, we can divide the we can classifying the compounds into carbohydrates based on their nature and molecule ion interactions. We can classify into different types. That may be the carbohydrate, lipids, vitamins, nucleic acids, proteins, amino acids. There are n number of classification of molecules are there, but some of them are called as the primary molecules. That primary molecules are the building blockers. This primary molecules includes carbohydrates, lipids, vitamins, nucleic acids, amino acids, proteins. Okay, these are the primary molecules. In that primary molecule, which they are having some specific structure and specific functions. Okay, in now we are entering into the carbohydrate structure. uh, in this carbohydrate structure, in this structure having the carbon, hydrogen, oxygen atoms, except this that won't having any functional groups. Carbohydrates only having the carbon, hydrogen, oxygen. The most carbohydrates are the in ratio is C 1% of C is to 1 is to O, C is to H is to O. This ratio is 1 is to 2 is to 1. The ratio between the CHO is 1 is to 2 is to O. That's only I mentioned that this is the ratio rapidly used, rapidly built in the carbohydrate. In this carbohydrate structure, we having the 6 carbon glucose system and 5 carbon glucose system. This 5 carbon is the riboglucose, that ribose that are called as the ribose. So some 6 carbon atom, 6 carbon carbohydrates are there. That is the carbohydrates called as glucose, fructose, that kind of structures. This all kind of carbohydrates are having the same structural similarity, but it's vary at one particular points. Okay. In upcoming I will explain in the detail about the structures. Function of this carbohydrate is it's an energy source for our cells, because all our cells are we having the functional pathways, right? Every cells having the pathway, that pathway producing the ATPs and convert the ATP to ATP, that producing the energy, that energy help us to activate our body system. This is the overflow of the human body system. In that every pathway want to activate, right? For that activation we need the energy. That fuel for the cell is the carbohydrate. Most you can see most of the biochemical pathways are start up with the glucose molecules or carbohydrate molecules. So that is very important thing in the cell structure, cell function activation. Okay, this also provide the strength and structure of cells. Here in the every here we for this example for this is our body cells are built up with the blood built up with the muscles, everywhere, every tissues are having the carbohydrate for they need the carbohydrate for their own cell structure construction. This is the basic concept of the carbohydrate. In this is the basic structure. This is the backbone. It's an example for glucose. Here you can see the backbone is a carbon atom, then having the OH groups and aldehyde functional group. This is the aldehyde functional group. It's very important because why I am including this means many of the changes happen in the aldehyde group, that hydroxyl groups are the exchangeable for between the molecules, that makes the interaction. Okay, the interaction makes the compound structure. If the single glucose for make the interaction with the n number of glucose, means that is called as the polysaccharide. Okay, here we know about this. Just I'm refreshing the concept. Carbohydrate, it's a primary molecule, is a monosaccharide. The monosaccharide is one sugar molecule. Monosaccharide means, saccharide means that is a carbohydrate mentioning word. Mono means a single, so single sugar molecule, that is the monosaccharide. It's a glucose, fructose, galactose. Disaccharide, two sugar molecules having structure, that is the sucrose, lactose, maltose. This sucrose, lactose, maltose are formed because of the addition of two monosaccharides. If there is a two monosaccharide present in one structure, that is classifying it into disaccharide, that is called as the sucrose, glucose, sucrose, lactose and maltose. Then oligosaccharide. Oligosaccharide means that are two two in isosugars. Same sugars are forming the one structure, that is the that is called as the oligosaccharides, that is the starchlose and raffinose. Raffinose is also comes under the the oligosaccharides. Then polysaccharide, it's 10 or more than 10 compounds of sugar molecules forming the chain like network. In that network only, that having only sugar molecules, that sugar molecules are interacted each other, that molecule is called as the sugar, glycogen and cellulose. Next is the lipid concept. After the understanding of chemical carbohydrate structure, the another primary molecule is the lipid. Lipid is why we need a lipid. For cell function, we need the lipid molecule. We need the glucose molecule. For cell construction, cell structure, they must need lipid for their cell wall arrangement. So every cell is having the lipid. In this lipid, that having two different types, that is a fatty acid and glycerides. In that fatty acid type, that having the saturated fatty acid, non-saturated fatty acids. If it is degradable with the enzymes, that is called as a saturated. That saturated lipids are that fatty acids are highly present in our human body. Then glycerides. Then glycerides are neutral glycerides and phosphoglycerides. They having two types. Then another one is these non-glyceride lipids and complex lipids. In this non-glyceride lipids, we can dividing three types, that is a wax, sphingolipids and steroids. The sphingolipids is called as that is divided into two types. Why I am mentioning this table means they provide the last sphingolines are glycolipids, and ask the question, it comes whether it comes under the non-glyceride lipid variety or it comes under glycerides variety. So it's a confusional one. They providing the last product. They mention the glycerolipids. Based on this word glycolipid, they ask the question whether it is the non-glyceride lipid or glyceride lipid. That is the question given. They based on this question, they ask glycolipid is non-glyceride lipid or glyceride lipid. Answer for this question is it's a non-glyceride lipid, but as per the in the point of view, exam point of view, we can't understand that situation. So we will give an answer. We will give we have a chance to give a wrong answer. So please remember, this flowchart is very important in the part B question part, because they providing the end name and ask what is the classification. Okay, next is the structure of the glyceride. 1 minute. Okay, structure of the lipid. In this structure of lipid, that having the this forms the fat, oil, cholesterol, as that is mentioned. The monomer of the lipid is fatty acid. Monomer of lipid is fatty acid. This fatty acid fatty acids are interact each other and forming the lipid. Carbohydrate monomer of carbohydrate polysaccharides are the glucose. Monomer of the lipid is fatty acid. This phospholipids having the three part of structure. That part structure having the head and tail. In that head, that having the glycerol and phosphate. Tail, in the tail they having the two fatty acids. It's a very important thing. The head having the glycerol and phosphate, tail having the two fatty acids. As I mentioned, this is playing the cell membrane function. Then another lipid is the first one is phospholipid. Then another one is the here triglycerides. In this triglyceride, that having the two structural part. That structural part is head is the glycerol, tail is the two fatty acids, three fatty acids. It having two parts. Head is glycerol, tail is made up of three fatty acids. Function of this is also the cell membrane flexibility. For phospholipids providing the cell membrane that make up the cell membrane. Function of this triglycerides is provide the energy to cells and insulation. And then glycerol, so cholesterol, this cholesterol gives the membrane flexibility. These are all the very important thing. Because they provide the in the one question itself they mention lipids, different variety of lipids. The different variety of lipids, they ask the phospholipid role that made up of this made up the cell membrane. It's like match the following type of question. We can tell the match the how the match the following is very important. The CSIR question, we can see nearly 20 questions with the match the followings. So I mentioned this. Please remember, phospholipids helps to cell membrane makeup. Triglyceride helps to cell provide the energy and insulation. Then cholesterol helps to cell membrane flexibility. Phospholipid structure having two parts, that having the glycerol and phosphate in their head, two fatty acids. Glyceride having the glycerol alone and tail having three fatty acids. This is the complex structure of lipid. In this lipid, 4 phosphocholine metabolism involved, so that there was 5 phosphate head groups are there in their head. That top part is called as the choline. This choline helps having the 5 phosphate group. Then the complex lipid metabolism, for lipase activity they need a phosphate having phosphate group. First one is phosphocholine. So primary phosphate, 5 phosphates are there. Here 3 phosphate helps to their lipid metabolism, that lipase activity. Then glycerol is there and 2 fatty acid chains. Then amino acids. This amino acid is another backbone of, it's a very important term. Why I am mentioning this amino acid structure before the protein means, the proteins are made up of the amino acids. These amino acids are the primary molecules to form the proteins. Just I recall that polysaccharides are made up of carbohydrates, that glucose, monosaccharides are glucose, fructose, that kind of things. the carbohydrates are made, monomers are glucose, monosaccharide. Lipids, the monomer of the lipid is fatty acid. The monomer of protein is amino acid. This is the whole concept here. This is the what I meant, what I wish to tell in this slide. The all amino acids are isolated from proteins. That is one example for alpha amino acids. The amino acid group having the carboxyl end, amino end, that is carboxyl end is the C double bond O, that having the one valency, it can interact with any functional group. Then amino group, amino end, that is the NH3, then side chain, and functional group R. The R functional group is basic interacting site for the various amino acids. Its amino acids having the backbone, the NH3, CH and C double bond O. It's same for all over most of the amino acids. The functional groups alone vary for all amino acids. In this protein they having many functions in the human body system. In that it having the very crucial role in all the body function. So that's a very very important thing. This protein structure is made up of CHO and N. N is the amino group. Here you can understand the protein is having the amino acids, so the number of amino acid N group is present in the protein. It's having some S atoms also, sulfur atoms also there. The all proteins are made up of the 20 amino acids. This is the fixed universal thumb rule. This thumb rule is helps to understand, okay, these cells are having n number of these cells are made up of only 20 amino acids. This 20 amino acids are arranged in different manner. That is helps to form a protein structure. Then secondary structure of the protein. First, the atoms, arrangement of amino acids alone, it's called as the primary structure. The primary structure, it's explained with the linear arrangement of the amino acids. Then secondary structure. These amino acids are making some interaction with each other, then that forming the helix and beta sheets. This if the binding of amino acids forms a helix spiral structure, that is called as the alpha helix. This alpha helix carries the 3 to 4 amino acids. This 3 to 4 amino acids are interact with the hydrogen bonding. In the helix they are having 3 to 4 amino acids. This 3 to 4 amino acids carries the hydrogen bonding. Then the beta sheets. These beta sheets are perpendicular bonding, that makes a perpendicular bonding to the polypeptide backbone. We can see it's a perpendicular bonding. It's in every you may search the protein structure that the beta sheets are always in straight manner. It's perpendicular to the polypeptide backbone. Then in this protein structure itself, that makes the polypeptides dipeptides. Dipeptides means 2 amino acids make the dipeptides. Polypeptides helps to a number of the peptide bonding. This that tertiary structure. After the primary structure, the amino acids formed interaction, right? That is maybe the peptide interaction. After that secondary structure, alpha sheet and beta sheet, alpha helix and beta sheet formation, that makes the 3D structure, that is the tertiary protein structure. This tertiary protein structure is the group of alpha helix and beta sheets. This alpha helix and beta sheets are looped by the loop region, that loop extension. These loops are made up of some atoms it's interacting, it's not interacting portion, that is forms a link between the alpha helix and beta protein sheets. In the this forming of the tertiary structure, that tertiary structures are making the quaternary structure. Quaternary structure, they having two different peptide chains, and this this peptide chains are forming the two different protein, that two beta sheets and alpha helix makes the tertiary structure. That tertiary structure is forms the that forms the protein quaternary structure. In that quaternary structure, two different protein structures are accumulate with that similar structure. Two different similar structure, that is called as domain A and B. The binding of domain and A and B, that forms the one structure. This one that understanding of protein structure with domains, that is comes under the that quaternary structure evaluation. Okay, now we are entering into the structure of the DNA. Previously we discussed the structure of carbohydrate, lipid, protein. Now this is the DNA structure discussion. In this DNA structure, that backbone, backbone is made up of the sugar phosphate group. Okay, sugar phosphate group. That sugar is the major thing. Here you can see the structure having the sugar molecules. That sugar molecules are interacted by the peptide molecules. This is the ribose sugar. In this ribose sugar, we have one option, that is the base binding. That bases are adenine, thymine, guanine, cytosine. I just want to let you know, if you went any bio life science company, if you are went to any bio life science company, research institute, they ask the first question they asked is the what is the structure of DNA, what is the structure of the adenosine, thymine, cytosine. It's very very important thing. Another thing is whether it is a pentose sugar or hexose sugar. Thymine having the hexose sugar as a base molecule. No, it's an it's a 5 molecules, it's a 6 molecule structure, benzene ring. Then adenosine having the pentagon in the structure. That is kind of one question. Another question is the what is the structure of the cytosine, what is the structure of the thymine. That question is most rapidly asked question in all interviews, CSIR examination and everywhere. First we want to please train yourself to draw the structure of amino acids, structure of glucose, structure of the adenosine, thymine, guanine and cytosine. This is the most important thing. Okay, here they mention sugar, bases. These bases are 4 types and peptide bond. In this image they mention how it interact. Okay, here you can see there was 2 bases, that is here is adenosine, then thymine. This adenosine and thymine makes interact with the hydrogen bonding. This hydrogen bonding it forms the bond between the thymine and hydrogen, that forms the disulfide bond. Adenosine thymine makes the disulfide bond, but the guanine and cytosine makes the triple trisulfide bond. Okay, the bonding is very important. It's a 2 bonding, and there is a 3 bonding is there. It's a structural difference between the molecules DNA and RNA. Here, this is in this RNA DNA that having the deoxyribonuclease. Here, this RNA structure having the ribo sugar alone. Okay, it forms an interaction. That interactions makes between the thymine, cytosine, guanine and adenine in the DNA. For replacement of thymine, we having uracil in the RNA. So in the RNA we having the cytosine guanine interaction and adenine and uracil interaction. Okay, what is the function? We already know about this, but I am refreshing this. It's having the hereditary function, and it's a genetic. It store the genetic information. It controls the function of cell, and it involves in many pathway informations. It promotes many pathways, because this is the major thing in cell, that is the nucleic acid. Here, sorry, because this is not visible to you, I know, but this is very important content, so I am included in PPT. I will send it to you as I am sent earlier me like that. Please refer this table. They ask the question like with this, based on this they ask some question. Here I am going to include the I'm just read out, because vitamin A, this is all about vitamins. Vitamins are the small molecules, it's all about the vitamins. Previously we discussed the DNA, protein, RNA, carbohydrates, lipids. Okay, now we are going to enter into the topic of the vitamins. In this vitamins, vitamin A having the 11 cis retinal visual cycle. This vitamin A involves in the 11 cis retinal visual cycle. Okay, the role of the vitamin A is that the retinal visual cycle. Then so it's called as the retinal acetate. Vitamin A is called as retinal acetate. Then cholecalciferol, this vitamin D3. This vitamin D3 is the cholecalciferol. This having the calcium and phosphate. It involves in the calcium and phosphate metabolism. Then vitamin E. This vitamin E is called as the alpha tocopherol. It's an antioxidant. Then vitamin K1, phytoadenone. This phytoadenone, it helps for the prothrombin biosynthesis. So it's vitamin K1. It's very important thing in the blood immune system production. So phytoadenine is a vitamin K1. This is helps to prothrombin synthesis. It's a match the following question, most widely repeated question. So please listen this. Thiamine is a B1, vitamin B1. It helps for the thiamine pyrophosphate adenyl group transfer. GPP pathway. That riboflavin, that is vitamin B2. It helps in different FDA electron transfer. Then niacin, it's a vitamin B3. It helps for the nicotinamide adenynucleotide. Then cyanocobalamin is called as the vitamin B12. It's a well known structure for all. It's a coenzyme for B2. Ascorbic acid, it's a vitamin C. It's a cofactor for hydroxylation. Then folic acid is vitamin B9. It helps for the tetrahydrofolic acid, one carbon group transfer. B amino benzyl acid, that is a vitamin, it's called as BABA. It's an antioxidant. The very small structure of antioxidant is the amino benzyl amine, that is called as the PABA. It's mentioned included for some important vitamins alone: vitamin E, vitamin C. This is the vitamin C vitamin 6 structure. In vitamin structure, C structure, they having the pyridoxine, pyridoxal, pyridoxamine, pyridoxal 5-phosphate. The the hero role playing compound is the pyridoxine. This is pyridoxine having the changing the functional group and makes the new compounds. Then cyanocobalamin, we all know, it's a vitamin B12 and ascorbic acid. Okay, next, this why I am mentioning this vitamins means the formation of the body structure, protein structure, everything, everywhere, they are having the molecules for the interaction. That may be the protein, that may be the lipid, that may be the vitamin, and anything. Because only I am mentioning the small chemical structures. Here in this slide I am going to explain the interaction stabilizing 3D structure. Interaction stabilizing is very important thing happen in the protein structure formation. In that we having the disulfide bond, hydrophobic interaction, hydrogen bonding, in ionic interaction, and van der Waals interaction. It's this is the one 2D image. Another one is here I am going to explain. Okay, in this chemical structure you can see hydrogen bonds are formed between the two sheets of the protein. That formed proteins are forming the loop, that was the packets, binding packets, the buried regions are hydrophobic interaction is there. Hydrophobic interaction, water free packet, that is the packets. Then that loop region having hydrogen bond between side chains and peptide group, that is the hydrogen bond between the peptide groups, that is forming the peptide bonds. Then salt bridges are also there, that bridges are formed between the amine and oxygen group. Another thing is hydrogen bond between side chains, here hydrophobic interaction and helical structure. Here they mention the same thing, hydrogen bonding, hydrophobic region, that is there was the van der Waals interaction. If you add any molecule at the hydrophobic region, that forms the van der Waals interaction. Then sulfide bridge, this sulfide bridges are formed between sulfurs, SS bonding, then ionic bonding. Okay, what is pH? This pH is called, we all know, it helps for the balance. It depends on the ions present over the solution or buffer, anything. The formula for the pH is minus log hydrogen plus, that hydrogen plus hydrogen molecules. It's decreasing the pH, there was increasing the acidity. This range of pH is the from 0 to 14. If it having the solution having the pH with the 7, that 7 mention that is neutral. The below to the 7 is called as acid, above to the 7 is called as the base solution. In the logarithmic scale, decrease of unit 1 is the 10x, its increase in H plus. The decrease of 0.01 unit is the 26% of hydrogen plus ions. Okay, Here they mention some examples for pH variation. If milk having the pH 7, human blood having the pH is 7.3, seawater having 8.1 pH, baking soda pH is 9, milk of the magnesious the milk of magnesious having 11 pH, a household bleach having pH 13, 14, 13 to 12, sodium hydroxide having the pH 14. These are all the basic base molecule. Then acid molecules, that black coffee having the acid 4 to 5, vinegar has 3, stomach acid is 2, lemon juice having 2, soda having 3. Then battery acids we are added the some liquid to the batteries, right? That battery acids having the pH 0. In the pH activation is very important thing. In this pH we have pH meter. The concentration of hydrogen ions is calculated through the rod. That rod having OH molecules and H molecules in particular manner. The interaction of this hydrogen molecule is measured in the system. In this instrument they having the reference cell that is filled with the neutral solution, that is a KCl solution. Then reference junctions are there. pH electrode bulb having the glass membrane. This glass membrane permeable to hydrogen plus ions. This pH meter is only activated by hydrogen ions. So acid ions having the more positive charges, so that is alkaline solution that produce the electric current, that makes some in current in that instrument. So that shown the voltage, from the voltage we can calculate the pH. Using this pH we are this basic concepts helps to develop the buffer solutions. These buffer solutions are made up of the compounds, waters, chemicals. This helps to balancing the pH of the reaction mixture. This reaction mixture having the if solution having the weak acid and salt of weak acid, we want to add the salt of weak acid. If the solution having the weak base, we want to add the that made up of the salt of weak base. It's a basic concept. This buffer is made up of the acid and base pairing. Without the acid we can't make the buffer solution. Without base we can't make the buffer solution. We need the acid and base in particular ratio. That is the buffer. Okay, buffer solutions is have the acid buffer and base buffer. Acid buffer means the concentration of acid is too high, but then having the base compound, then basics. Then reaction kinetic. In this reaction kinetic we are having the energy changes during the reaction, that is measuring of energy changes during the reaction is called as the reaction kinetic. The effect of temperature on the rate of reaction, it's denoted by the experimental values, that is the reaction kinetics. The minimum amount of energy is required for the activation energy, that is called as EA. This EA is the developing a reaction. Thus those reactants are very energy equal to or greater than the value of reactor. In this based on the chemical reaction kinetics, in this life science people are studying the chemical reaction kinetics. In this chemical reaction kinetics means here they mention the A plus B forms the C plus D. For that equation, reaction kinetic equation, you can develop like this. The reaction rate uh, is depends on the reaction rate constant, exponential factor, reaction activation energy, gas constant, temperature value. All the things are comes in the equation. These are all the kinetic parameters. Reaction rate constant, pre-exponential factor, reaction activation energy, reaction order. These are all the kinetic parameters. This kinetic reaction measuring, we are using the Arrhenius equation. This equation is called as K equal to A naught exponential E minus EA divided by RT. They provided the symbol and asked the question, okay, what is the exponential, what is the expansion of A naught? It's a pre-exponential factor. What is EA? It's a reaction activation energy. What is KA? K, it's a rate constant. After that understanding of your solutions, understanding of the reaction kinetics, the thermodynamics plays a major role. What is the role of thermodynamics means? This thermodynamics helps to understand how the thermal, that is the heat, it's move between the material, work, heat, energy comparison. Thus thermodynamics we having the two part, the equilibrium, thermal equilibrium and zeroth law of equilibrium. The thermal equilibrium, they obtain energy between two molecules but through the direct contact. In the zeroth law of thermodynamics, two systems are separated and found in thermal equilibrium with the third system. The third system pass the heat. This colligative property of the solutions is very important. It depends only on the number of solute particle in the solution. Number of solute particle in the solution is not the nature of the solid particle. It's a number of solute particles in the solution. The vapor pressure lowering means that having the P1 equal to X1, P0 1. Here they mention X is the molecule fraction, M is molarity, I want half factor, R gas constant, M molarity and T temperature. We are having three different equations. It's very important and asked question in the CSIR question. Boiling point evaluation, freezing point depression, osmotic pressure. The all things having different equation. P1 is equal to X1, P1 not, delta Tp, delta Tf. Delta Tp means the boiling, delta Tf means freezing. It's having the IK, B, IK, F, M. Osmotic pressure IMRT. In this bioenergetics, we having it's a application of all previously discussed thing: atoms, molecules, lipids, proteins, structures, chemical bonding. All the things are accumulated and collectively reported in the bioenergetics, because this bioenergetics is the quantitative study of energy transformation in the living cell. Very important thing. The qualitative study of energy transfer in the living system. This organisms needs energy to their physical activities. These physical activities are makes for that physical activity, there are n number of chemical reactions takes place in the human body. It's one example. Here you can see the chloroplast helps for the photosynthesis. It provides glucose and oxygen conversion and activating the mitochondria for cell repression. This from the mitochondria, the water and CO2 using released, and it helps to the cytoplasm for light energy, using the light energy that producing the start the process photosynthesis. Here the activation of mitochondria is the chemical energy production. This all the things are starting with the glycolysis. In the glycolysis, glucose converted with the that's here in this image. The enzyme names are very important. Glucose to 6-glucose phosphate conversion, hexokinase. Hexo, it's a 6 right. So this glucose 6 phosphate conversion, then phosphoglucose isomerase. The similar isomerase means similar formation. So glucose 6 phosphate forming the fructose 6 phosphate. Isomer of the glucose is fructose, so it's called as the phosphoglucose isomerase. Then phosphofructokinase. Phosphofructokinase means here this phosphofructokinase helps to hexokinase are always converting. Here it's fructose converting the fructose 6 phosphate into fructose 1,6 bisphosphate bisphosphate. This 1,6 bisphosphate is divided into two types, that is the glyceraldehyde 3 phosphate and dihydroxyacetone phosphate. Dihydroxyacetone phosphate. It happens because of aldolase. Okay, then these two molecules are triocephosphate isomerase activity that forms the new thing in glycolysis process. Output of the glycolysis process helps to activating the another glycolysis pathway. Here bioenergy is having the oxidation, phosphorylation, all the things that happen in oxidative phosphorylation. This happens in the human body. In this oxidative phosphorylation, in the first step oxidation happen in the electron transport chain. Here it's produce NADH plus H plus O2 ions utilization that produce NAD. NADH molecule is converted into NAD. FADH2 molecule converted into FAD. Phosphorylation step that produce the ADP plus API phosphate group to form the ATP. In the end of the reaction, its glucose is converted, that glycolysis pathway. The output is helps for, if the output helps for another reaction that is called as a coupled reaction. The two reactions mingled one. In this coupled reaction, one is called as the enterogonic and exogonic. In the enterogonic, it's called as energy from cellular respiration. Take the energy from the cellular respiration. The exerogonic, the energy for cellular work, it's providing this energy for the cellular work. First one is endogonic. Enterogonic, it helps to energy respiration. Exergonic, it helps to energy for cellular work. During the enderogonic, ATP is formed. During the exergonic, ADP is formed. The output of the function of exergonic is called as the heat energy. You can see here the glucose binding forms the sucrose, that is a uncoupled reaction. Here in this glucose is added to the ATP that forms the ADP, and it forms the glucose phosphate with the phosphate group. This glucose is input for next step. This next step forms the glucose. That's a two-step process called as the uncoupled reaction. In the phosphoryl group transfer, first one is the phosphate group transfer. Here they forming the coupled reaction. Then group transferring, the transfer of groups that having very important thing in the all the chemical structure discussion. In this, adenine and ribose is there that forms the interaction with the glucose functional molecule. That glucose makes the sharing the ions atoms at the phosphate group that forms ADP and glucose 6 phosphate phosphate ester. This is the phosphate group transfer function. Another one is the nucleic acid acyl substitution. It's a functional group transfer between the nucleophilic acetyl substitutions. Here the molecule is replaced. Here you can add the nucleophilic. The nucleophilic it's interact with the C molecule carbon. Addition of this nucleophilic to the structure that remove the one functional group with the oxygen. That is the transfer between atoms. Here transfer between the membrane. The membrane and as an energy transducer, this membrane having the outer left inner leaflet, the membrane having the integral membrane protein, asymmetric chemical environment. Previous classes itself we discussed, right? Cell membrane having the n number of the proteins, GPR proteins, membrane transducer protein, that all things are there in the membrane. Here the next thing that proteins are help to transfer the ions from external to internal, internal to external. The another one is the catalysis. Catalysis means the it's increase the rate of chemical reaction. In the normal reaction having the slow reaction rate. If you want to increase the slow reaction rate, we want to add the catalysis. It provides the site for the reactant to be activated. The activation of the reaction it's happen at the early stage. It's a basic thing. Where we can use it is a catalytic catalysis process. Thermodynamics and chemical thermodynamics carries the this catalysis process. Catalysis is a lipid increase the chemical reactions, provides the reactant for the activity. Then enzyme kinetic concept. In this enzyme kinetic concept, the overall reaction is composed of two complementary reactions. So here enzyme and substrate addition. This enzyme and substrate addition forms the ES complex. This ES complex is forming the product and the E molecule. Here all the process in the single step only E and S alone formed. This formation induced by some catalysis compound that forming the product. This enzyme kinetics we are having some important terms, that is the that monitor rate of enzyme catalytic reaction, that is depends on the change substrate concentration, pH, temperature. The enzyme reaction catalysis reaction is depends on the substrate concentration, pH, temperature. In the reaction we having the curve. That curve having the based on the enzyme reaction we can draw the curve. Then that curve we can calculate V max value. The maximum curve reaching region is called as V max. The 1/2 is 1/2 V max is the very important thing in Mechels-Mendel enzyme equation, kinetics equation. It's all about the you are all studied in biochemistry. Just I am refreshing this, only I am going in fast manner. In first order kinetics, the reaction rate depends on the concentration of only one substrate, that is first order kinetic. Its reaction rate is depends on only one substrate. In the second order kinetic, the reaction rate depends on two substrate, that is the biomolecule reaction. In the pseudo first order kinetics, the reaction rate depends on the concentration of only one of two substrate. There was two substrate in the reaction, but the kinetic order is depends on only one substrate. Then zeroth order kinetics, the reaction rates depends on the concentration of substrates, all the substrates. Here allosteric inhibition and the allosteric activation. The allosteric inhibition is a very important thing. Some of them may know about the molecular docking studies, drug binding composition. All the things are discussed with the protein inhibition. Every disease we want to inhibit the protein, like corona itself we want to inhibit the spike protein. If we are inhibited the spike protein, we can easily overcome the viral infection, but we are not able to find. Why? Means this is the enzyme having an active site. It's the only active site for the substrate binding site for enzyme. If this is in active form, if it's a disease protein, means that a substrate is bind at the active site. The substrate is we want to avoid the binding of the substrate at the active site. So if we are adding the inhibitor at the active site, but if it is not possible to your reaction, your drug developmental study, you can add the inhibitor to the other site of protein. This binding makes the change in the active site. You are added the inhibitor at various site, but that makes the change in the active site. So here you can see the second image, they are mentioned there is no active site for substrate because of the protein structural change. Once you adding the one inhibitor at one site of protein, there was some chemical bonding is formed, right? That formation of the chemical bonding alter the active site. Then allosteric activation, that is a similar process. There is no active site. So if you are adding any inhibitor or any compound to the protein structure, that makes a chemical bonding between the beta sheets and alpha helix. That chemical bonding makes the change in the structure. It's another one is a feedback inhibition. Feedback inhibition means if you are in earlier stage we have studied, right, there was a hormone balance imbalance. So avoiding the hormonal imbalance, we are added the enzyme pathway is activated. The activated enzyme pathway is producing some signal. So due to the signal, the production is stopped. Likewise, here we having the feedback inhibition. In that feedback inhibition, one particular pathway is producing the one compound, that is the if that enter in going to active site, that active site it's bound at one active site, so production is stopped. Synthesis of amino acid isoleucine, and from the amino acid threonine. Threonine is helpful for production of isolation. Isolation become a allosteric inhibitor for the first step of the pathway. Here they are producing the threonine, using the threonine, the binding of threonine at the threonine deaminase. Here you can see this is a deaminase. This deaminase substrate is the threonine. This pathway is producing the isolation. It's a catalytic activity reaction of enzyme catalysis. This is a very important thing in this image. The activity of the chymotrypsin depends on the histidine 57 and serine 195 in the portion of this particular peptide chain activation of the pathway. It's a two-step nucleophilic mechanism. In this peptidase activity, why I mention this means many of the questions are rapidly asked. The question depends on the peptidase and esterase enzyme activity. So only I am mentioning this peptidase and enzyme esterase is the very important enzymes in the catalytic activity. This catalytic activity, the chymotrypsin is very familiar example. It helps to the reaction, helps for the reaction mechanism of the enzymes. It's a binding of chymotrypsin at the binding site histidine 57 and serine 47. It's positionated to close the proximity within the active site of enzyme because the folding of the peptide chains is happen. The mechanism of enzyme catalytic activity is it's example for the previous is a substrate. added to the enzyme. If you added the enzyme, it perfectly matches with the substrate, that forms the enzyme substrate complex. This enzyme substrate complex, it helps to form the product. First step is this one, then decomposition of the enzyme activities. So enzyme catalytic activity, again I mentioned why I am mentioning repeatedly means this is the very important concept in the enzyme kinetics. The substrate, enzyme substrate binding, enzyme substrate complex. Here the active site is there, so but complex is formed. It's another one thing. Then enzyme product complex, this is the thing. Various examples, because sometimes that enzyme and substrate and product having the same structure, that is called as isoenzymes related concept. So this image represents the isoenzymes concept. The isoenzymes means it represents the enzymes from the different gene that process and catalysis are same. That gene A and B producing the same enzyme, that's the same enzymes are having same structure and function, that are called as the isoenzymes. Okay, I am partially covering the unit 1. Tomorrow we are going to discuss about the important topics, the conformation of the nucleic acid A and B, that structure forming, then proteins, then tomorrow we will discuss the cellular organization. Thank you everyone. Today as usual I am take more than 1 hour, sorry. Thank you for your patience. Now I am going to end this section. If you have any questions, please type it in chat box. Already yesterday questions also I am not answered. Today I will answer that questions also. If you have any queries, please ask in chat box, and if you have any later itself you can post the questions in Google Classroom on mail. Yeah, okay. Kanagadevi, phospholipids having 3, ma'am, you said right, in that protein itself, 1 minute, I'll reopening that, going to that. I think you're asking this, right? Having 3 part phospholipids, right? 3 part, the 2 part is glycerol and phosphate. Glycerol is 1 part, phosphate is 1 part. That 2 parts are present in head. Tail having fatty acid, that is 3rd part. In triglyceride, 2 parts alone, head and tail. In the head they are glycerol alone, tail that having the fatty acid alone. Fatty acid is a part, 2 fatty acid present over there. Once again I am repeat, in the phospholipid structure having 3 part. That 3 part is glycerol, 1 part is glycerol, 2nd part is phosphate, 3rd part is fatty acid. In triglyceride having 2 parts alone, 1 part is glycerol, 1 part is fatty acid. Thank you everyone. Thank you for your patience. Now I am going to end this session. Tomorrow we will discuss some remaining part of unit 1 and unit 2.